You know how sometimes you see an average and you just get this feeling like that can't be the whole picture, right? Well, you're not wrong. An average, all by itself, can be seriously misleading. It often hides the real story underneath. So today, we're going to look past the average. We're going to uncover that hidden story using 3 key tools: range, variance, and the really important one, standard deviation. Let's dive in.
So here's our game plan. First, we'll see exactly how an average can fool us. Then, we'll start our investigation with our first clue, the range. After that, we'll upgrade to a better tool called variance, before we get to the gold standard, standard deviation. And that's what we'll use to crack the case of consistency versus risk. Finally, we'll zoom out and see what this all means beyond just the numbers.
All right, let's kick things off with a little mystery. Imagine you've got final exams coming up and you need to pick a study group. You've got 2 choices, Group A and Group B. And luckily, you've got their past test scores to help you decide. Now, on the surface, they might look pretty similar, but our job is to dig deeper and figure out which group is actually the better bet for your grade.
Okay, here's the raw data. Take a look at Group A. Their scores are 84, 85, another 85, 86, and 90. Seems like they're all kind of bunched up together, right? Now, look over at Group B. 70, 75, 85, 95, and a massive 105. Whoa. Those scores are, well, they're all over the map. So the first most obvious thing to do here is find the average.
And here's our first big plot twist. You crunch the numbers, and the average score for both groups is exactly the same, 86. Yep, on paper, just going by the average, these 2 groups are completely identical.
So this is the million-dollar question, isn't it? If their average performance is identical, how in the world do you choose? Does it even make a difference? This question right here, this is exactly why we have to look beyond the average. The answer isn't in the middle of the data, it's hiding in the spread.
To start cracking this case, we need our first investigative tool. It's the simplest way to measure spread, and it's called the range. It's a decent place to start, but as we're about to see, it has a pretty big flaw.
So what exactly is the range? Well, it's pretty much what it sounds like. You just take the highest value and the lowest value in your dataset, and you subtract one from the other. Boom! It gives you one quick number that tells you how far the data stretches from one end to the other. Let's try this with our study groups. For Group A, the highest score is 90, the lowest is 84, so the range is just 6 points, super narrow. But then we look at Group B. Highest is 105, lowest is 70, the range is 35. Okay, now we're getting somewhere. Suddenly, these 2 groups with the same average look worlds apart. This is our first real clue. But here's the catch. The range is simple, maybe a little too simple. It only pays attention to 2 scores, the absolute highest and the absolute lowest. It completely ignores everything happening in the middle. This means a single extreme score, an outlier, can totally throw off our understanding of the spread. So yeah, the range is a flawed detective. We need something better.
And that brings us to a much more powerful tool, variance. See, unlike the range that only looks at the bookends, variance takes every single data point into account. It wants to know the full story of how each and every score relates to the group's average.
So how does this work? Let's break it down. We start with our center point, the mean, which we know is 86. Then, for every single score, we measure how far away it is from that mean. Now, step 3 is the really clever bit. We square all of those distances. This does 2 brilliant things. First, it gets rid of any negative numbers, which is handy. But more importantly, it gives way more weight to the extremes. A score that's far from the mean gets penalized a lot more. Finally, we just take the average of all those squared distances. And that number? That's our variance.
Now, variance is awesome, but it does leave us with one kind of weird problem. Because we squared everything, our answer is in squared points. I mean, if we're talking about a test, what in the world is a squared point? It's not exactly easy to wrap your head around. We're so close to the perfect measurement, but we just need one last step to make it make sense.
And that final step, my friends, brings us to the hero of our story, the standard deviation. This is the tool that takes all the statistical muscle of variance and translates it back into a number that's actually intuitive, something we can understand. It really is the gold standard for measuring spread.
The magic of standard deviation is actually really simple. It's just the square root of the variance. By taking the square root, we undo that squaring step from before, and that brings our measurement back to the original units, in our case, back to test points. So the final number tells us, on average, how far away any given score is from the mean of 86. It's the standard amount of deviation.
Okay, moment of truth. We have our ultimate weapon, the standard deviation. We're finally ready to go back to our study groups and solve this mystery once and for all. And this isn't just about finding a number. It's about what that number tells us about the personality of each group. This really gets to the heart of it all, using data to understand that classic trade-off between consistency and risk.
Let's start by visualizing Group A. See how the bars are all huddled together? They're tightly packed right around that average of 86. This is what consistency looks like. I mean, think about studying with this group. It's reliable, it's predictable, you know pretty much exactly what you're going to get. No huge surprises. If you've got a million other things going on and you just need to lock in a solid B without any drama, this is your team. It's stable, dependable, you're not shooting for the stars, you're aiming for a safe, solid landing.
And now, Group B. The picture could not be more different. These bars are all over the place. It's a perfect visual of huge variation. This is unpredictability. Joining this group is a total gamble. It's risky. The dynamic could be amazing, or it could be a complete disaster. You might get pulled up to an A+ by that one person who scored 105, or you could get dragged down to a C by the person who got a 70. The outcome is a total question mark. This group has high potential for sure, but also high danger. It's the classic high-risk, high-reward choice.
And now let's put some numbers to what we just saw. Group A's standard deviation is about 2.3 points. That means a typical score in this group is only about 2.3 points away from the average. That is incredibly consistent. Now look at Group B. Its standard deviation is a whopping 13.6 points. A typical score here is more than a full letter grade away from the average. Just think about that for a second. In Group A, a normal day is getting an 84 or an 88. In Group B, a normal day could be a 99 or it could be a 72. That is risk in a nutshell.
So let's just lay it all out. A low standard deviation, like we see in Group A, means consistency, reliability, predictability. A high standard deviation, like in Group B, means variety, unpredictability, and risk. So, which group do you join? Well, it totally depends on what you're trying to achieve. If you just need a solid B to pass, Group A is the no-brainer, safe choice. But if you're already an A student and you're trying to ace the final, maybe that high-risk, high-reward chaos of Group B is a gamble you're willing to take. The better choice is all about your personal tolerance for risk. And this whole idea is so much bigger than just some made-up classroom example. This exact same logic, using standard deviation to weigh consistency against risk, is used to make decisions worth millions, even billions of dollars every single day, especially in the world of finance.
Check this out. It's the same exact story, just with two stocks. Just like our study groups, they both have the same average return, 5%. But their risk profiles? Totally different. Stock A has a low standard deviation of 2%. It's a consistent, reliable investment. That's our Group A. But Stock B has a standard deviation of 10%. In finance, they call that volatility. It's unpredictable and risky, just like our Group B. An investor who wants a safe retirement is going to pick Stock A every time. But a day trader willing to risk it all for a huge payout, they might go for Stock B. They're using this exact same math to measure risk.
So as we wrap things up here, what's the big takeaway? What is the story that this idea of spread tells us that an average just can't? Let's quickly recap what we figured out.
First, and this is the big one, an average by itself can lie to you. Second, it's the spread of the data that tells the real story, that story of consistency versus risk. Third, standard deviation is the best tool we have to put a number on that story. And the rules are pretty simple. Low standard deviation means the data is all bunched up and consistent. High standard deviation means the data is all spread out and risky. So I'll leave you with one final thought to chew on. Think about all the averages you see every single day. The average time it takes to get to work, the average price of coffee, the average weather forecast. Now that you know about spread, ask yourself, what story of consistency or of risk might that single number be hiding?